only nonmetals in covalent compounds. So made of only nonmetals. Remember, nonmetals are on the left or right side of the periodic table? The right side. Tell me about the electrons. We saw with ionic compounds on the last homework, we saw the arrows, the give and take of electrons, but is that the case this time? The electrons are what? Electrons are shared between the nonmetals. And this sharing works so that everyone can have how many valence electrons? Okay, so the overall goal is still to have 8 valence electrons. That's still our goal. So the things that we have to be doing today. Our task. Our task is pretty simple. We have to, 1, be able to write the structure of a covalent compound. 2, determine if the compound that we have just drawn is polar or nonpolar, and I'll talk more on that in just a second. And 3, which we're going to be working on over the next 2 days, is to determine the shape of the molecule. What does it look like? Okay, so I'm going to show you some examples real quick, and let's run through some of these examples. Pay close attention because this stuff is a little crazy. So I'm going to show you how to do this, at least steps 1 and 2 for today with some of these examples. The first example I'm going to get you to do is methane, which is CH4. So I'm going to get you to write that down real quick. And I want you to write down under this how many valence electrons does carbon have and how many valence electrons does the hydrogens have. And that's a 4 right there for 4 hydrogens. So CH4, tell me how, get total electrons real quick. How many valence electrons does the carbon have? Valence electrons. 4. How many electrons does the hydrogen have? that have 1, but there's 4 of them, right? So each hydrogen has 1, but there's 4 hydrogens. So if we add up all of our electrons, how many do we have here? So we have 8 to use. So that step 1 that we just saw was basically to count all of your electrons. So we could label that as step 1. Determine total number of valence electrons. Now step 2 is to just kind of simply draw this out a little bit. And to do this, we're going to place the smallest element, the smallest number of a certain element. So place the single element in the middle. Now, which element here would probably go in the middle, the carbon or the hydrogen? Yeah, because there's only one of them, correct? So we could envision putting the carbon in the middle and the hydrogens around it. Again, this is doing Lewis structures of covalent compounds because you've got only 2 nonmetals here. So you would know this is covalent right away from the beginning, and I probably should have gone over that a little bit before. But covalent because it's got C's and H's only in it. Now, hydrogen is an exception to the rule of 8. Hydrogen only wants 2 valence electrons. So maybe I think everyone might want to listen very closely when I say that hydrogen only wants 2 valence electrons. So, how many electrons do I need to draw around the H and the C right there? There needs to be an electron between that this H is bringing. This H is bringing an electron. This H is bringing an electron, and this is H is bringing an electron. Right? How many valence electrons does H have? 1. So there it would be. Correct? How many valence electrons does carbon have? Now they are sharing these electrons, so I could draw in with a different color. Use this color. A line that's connecting those 2 electrons in each case. Right here you have seen your covalent bond. Remember in the ionic bond, like you did it for the homework, there was the brackets with the pluses and minuses going on, the give and take of electrons with the arrow. Here though you see that there's a sharing bond. How many electrons are in each bond? Very good. Each covalent bond has and remember, in step 1, you're counting out the total number of electrons in the valence level, so go ahead and count those electrons out. Count out how many electrons the carbon has in its valence level, how many oxygen has in its valence. Carbon has 4, right? How many carbons are there? Oxygen has how many? 6, but there's 2 of them, so what is that? 6 times 2 is 12? Plus 4 is, so there's 16 valence electrons total. Now jumping over to step 2, this area over here, which element do you think is going to be in the center? The C would be. And the oxygen would be on probably opposing sides, right? That makes sense. Now, it might take some practice, and I'm going to do this with pencil to show you kind of the different thoughts that could be in your head. But how many electrons does the oxygen have naturally? 6, right? And the carbon has 4, right? So we can think of 1, 2, 3, and 4. But really, it would be unlikely that, I mean, we need probably the electrons only on one side of the C and on the other side of the C. We need them to both be going to the oxygen direction. So it might be more appropriate to draw a dot and a dot and a dot and a dot. How many electrons does each oxygen have? We could do 1, 2, 3, 4, 5, 6. But to me, the problem with that would be that we're not bonding with the carbon at all. So maybe we need to move one of those sets to right there. Let's do the same thing to the other oxygen. Those positions. Now, how many bonds am I going to make between the left oxygen and the carbon? Yeah, you can see a bond that would be formed right there, and right there. And a bond that would be formed between this one and this one. Now, before we get too far, let's count up. How many electrons, how many dots do you count? How many dots around the entire thing do you count? 2, 4, 6, 8, 10, 12, 14, 16, 16? How many dots? And I'm going to go ahead and make these dark now. Dot, 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 dot.